maybe. Let's go over them because they're very necessary. So this is P2. I believe the title is Exponents. You're right, slower, and radicals. Okay. So here, so radicals honestly is just a special case of exponents, right? Radicals are fractions, fractional powers, fractional exponents. It's the only real difference. But they got their own notation and symbols just because, they're special. But let's go over the rules. So number one, actually, let's define things first. Let A, B, M, and N be real numbers. So number one, A to the N times A to the M. What happens when you multiply? Right, we've done this before. There's a bunch of them. Division. You subtract them. If you raise a power to another power, you multiply them. If you raise a fraction, let's say A over B. I forgot to put that B is not 0. If you raise a fraction to a power, they both get the power. Okay, is this familiar? So make sure you have all these on a formula page or whatever, just in case. Let's see, what else? If you have a negative exponent, you can bring it down to the bottom and make the exponent positive. Or if it's negative on the bottom, you can bring it to the top and make it positive. So basically, you can move this guy up or down however you want. But whenever you shift it, if you cross the line, you change the sign. Okay, that's all. All right. If you have a negative on a fraction, you can just flip it over and change it to positive. Okay. I want to say that's all of them. Yeah. For oh, actually, we can add the radicals right here. I'm just writing. All I'm doing is writing the rules of exponents. All I'm doing. These are properties. We haven't started any problems yet. Number 7. Let's see here. All these are from like high school algebra. You've done all this before. They might have been written differently, but it's the same thing. Number 7, if you have an index on your radical like this, that's the same as saying a to the 1 over n. So this is just a fractional power, where n is not equal to 0. Number 8, if you have a power inside here, then you can write this as a to the m over n if you want. You can also write it as the nth root of a and then put the m out here. These are all equal. Sometimes it helps to shift however you want. It just depends. Depends what you're doing, Okay. Anyway, so these are all the things that the class assumes you memorized a long time ago, but I'm not going to assume that. That's why we're talking about it now, just in case. So, open P2 on the homework. I'll switch to this in a sec. Can you guys see the homework? So open this guy up, P2. So I'm gonna let the videos and the book talk about the theory. Here we're just gonna try to learn how to do the homework. How do we solve this? What do we do? The first few questions are just definitions. Okay. So we'll leave that to you. It's no big deal here. This is something I did not mention. If you have a plus some kind of radical, and the conjugate pair would be a minus that same thing. So for example, let's say you had square root x plus 2. Square root's separate, it's just ends right there. The conjugate pair would be just the same thing, minus 2. Okay. Or if you had 3 plus square root 7x, right? The conjugate would just be 3 minus this. That's all conjugate means. Okay. Okay, in case you forgot. Okay. Yeah, pretty much. They're related to the difference of squares. Do you remember difference of squares? A plus B times A minus B. Very similar. They're kind of opposite signs, but same. But everything else would be the same. Okay. Number 7, very basic, right? Square root of 9, well, you know how to do that. Cube root, you need to separate them and then do them separately. I know that these might be very easy, but remember what the note says. Technically, this means you can cube root the top, and then cube root the bottom. What is the cube root of 125? What is the cube root of 27? Are you guys not comfortable with cube roots? Yeah, look for P2. Yeah, cube root of that is going to be 5. And the reason, right, if I rewrite the 125 as a 5 cubed, should probably do this on the paper, and rewrite this one as a 3 cubed, right? 3 times 3 times 3, you agree is 27, right? So these will cancel. So by definition, right, you're only left with the 5/3. Oh yeah, the numbers will be slightly different for everyone, but it's the same question. Just the numbers will change. Sometimes they don't, but I mean that doesn't matter, right? All right, but big picture. Let me see what number 8 is before I move on. Yeah. So I'm gonna write these down on the paper because it is hard to write on this guy. So 7 and 8 is what I'm gonna work on. Yours might be different. If you want to work yours, that's fine. Just do the same type of thing. Okay. This is number 7 from the homework. It says to use a calculator, but let's not do that. Because the point is to understand why they reduce, right? Like, why is square root of 4 2? What does that mean? So, square root of 9, the reason that it's 3 is because 3 squared and square root are inverses of each other. But if you change this and into powers, right? A square root is technically a 1/2 power. So we said the index square root meaning 2 root 2 would be 2 here. So 1/2. So square root of 9 is technically 3 squared, right? Which is 3 squared to a half. You see how this is all the same? Using all these properties here, right? From back in the day, we can show why square root of 9 is 3. So right here, you have 2 times a half because of property number 3. 2 times a half is a 1. 3 to the 1 is a 3. So this is why square root of 9 is 3. It's because all these cancellations happen. Right? We just memorized it back in the day or used a calculator, but this is why. And this is what the rules of exponents let you do. Does that make sense? And bear with me, I know this is review. I don't mean to bore you, but it's just got to go over for a little bit. It'll get harder later, don't worry. Cube root. We'll just redo this real quick on paper. The reason these cancel is because they match the index. The powers match the index. Right? So right here, this becomes 5 cubed. I mean, you could skip this step here if you want, but just because we're doing it for the first time here, the index becomes a fractional power. 3 times a third, that's going to be 1. 3 times a third, again, a 1. So the answer is 5 over 3. Okay. Is there any questions on what we're doing here for part A or part B? I'm going to move on to number 8 in just a moment. If you don't have questions. Are you guys cool on this page before I turn the page? I'm going to scan the notes to you and I'm going to send the video to you via Remind. Okay. Usually the day after. Right. I'm assuming you're good then. But change your mind, let me know. Okay, let's do number 8. Simplify. So part A on my example has cube root of 7 to the cube. As we said before, if the powers match, right, it's going to cancel. So what do we have here? We have 7 to the 1/3 to the third. What are the rules of exponents say when you have a power raised to another power? I want to say that was rule 3, I think. Yeah, just let's multiply it. So we get 7 to the 1/3 times a 3, which is 7 to the 1, which is why this is a 7. Right? The answer is 7. That makes sense? Any questions on part A? Just let me know at any time. Okay. We can always backtrack, no big deal. So here, it looks like something might cancel, right? It's very tempting to cancel this 3 and that 3, but we got to first set it up because this 8 needs to be changed. So this is a 2x cubed. You see what happened? Let's show an extra step. So this is 8 is technically a 2 cubed, and the x is already cubed. So if they're both cubed, you can rewrite it as a single factor cubed based on, where is it? I did forget one. It's an extension of 3. If you have AB to the n, you have AN BN. So, oh man, it's smeared everywhere. So we have 2 cubes, so you can put the whole thing on 1. Like that. So now, this becomes 2x to the 1 to the third, and then 1/3. So the same cancellation is going to happen, right? So this will be 2x to the 3 times 1/3, which is 2x to the 1. So the answer is just 2x. I'm showing extra steps because we're going over it. So if you skipped 1 or 2 steps here and there, that's okay. Don't skip too many, but I showed extra just in case. Any questions on number 8? All right, let's do 9. Square root of 12. So whenever you're simplifying a radical, you want to factor the number inside, or whatever is inside, into squared factors, because we've just learned, right? We're noticing that they need a match in order to cancel. So I need something that's square to cancel a square root, right? That makes sense. So purposely choose squared factors. So we also have a rule that says you can separate radicals when you have multiplication, not addition, only multiplication. Can you break them like this? Square root of 4. We know what it is. We don't have to show all that work. Square root of 12 will become 2 root 3 because of this, right? Separation and then simplify. Any questions on part A? Okay. So for square roots, you're looking for squared factors. So what do you think cube roots is? What do you want to look for in cube roots? Yeah, exactly. So I don't expect you to have all the cubes and all the squares memorized. So if you want to have like a sheet of squared numbers and cube numbers, I don't care. You can Google it if you want. What matters is can you do the process here, right? If I didn't know there was a, if I had a list of all the squared factors, I would hope you'd see, oh, 4 goes in there, cool. Over here, if you have a list of cubes, you should see that 125 would be the best one, right? 125 times 2 is 250, correct? Separate this. So cube root of 125 is 5 times cube root of 2. Any questions on how we did that? Like I don't expect you to know right away how to find this number, so, but Google a list and you'll see, or print one out of all the cubes. That way you know, okay, 125 goes in here. You want to pick the biggest one, because if you don't, you might have an additional step at the end. It's not wrong, you'll create more work. Yeah, pretty much. You want to find the biggest one. So just do 2 cube factors, just like we did before, 2 squared factors. Andrew, which one? I'm sorry. For this one? Okay, so this is what let's look up cubes together. You can see what I'm saying. Maybe this will have it. Adding images is the way to go. Yeah, these tables. Do you remember these tables from way back when? These are all the cubes. Oh, here they are. Can you see this? All right, 1 cubed is 1. 2 cubed is 8. So I'm trying to find these numbers here on the right that are factors of the number inside. So I saw the 250, and I just have it to remember that 125 is one of the cubes. So I'm like, okay, well, if I factor 2 times 125, I know the cube root will cancel this guy, giving me a 5. Just like the square root of 4 becomes a 2, right? Square root of 64, etc. Oops. So have a list ready if because I don't remember all the cubes personally, so feel free to print out the squares and cubes. I don't care. Just make sure you know how to factor two numbers. Remember that you can factor and separate radicals. At this point, you should see this becomes where's my pencil? You'll see that this becomes a 5, right? Okay. Any other questions? That's pretty much number 9. Number 10, we've kind of already talked about that. Let's move on. They're just reducing fractions. We'll go over it real quick, but you see how it's a cube root, but it's a fraction, square root and fraction. So you're doing the reducing that I just did right now. But instead of having a single one, you got to separate these into 2 and then do what I just did. So it's the exact same thing, just one extra step. Does that make sense? If it's bothering you, we can do it. If not, I want to move on to 11. So let me know. Okay, let's do it. Let's do B. B looks more chill. I think this will make more sense. Let me switch back. So 32 over 49. So what you want to do is separate them. Assuming the fraction doesn't reduce, right? If it does reduce, cool. Do that first, but up here you have 32. So what is the squared number that we should factor out? On the bottom, we're good, right? That's just a 7. Four does work, but we want to pick the biggest one. What's a bigger a squared factor? Yeah. So we want to choose this one. Otherwise, we'll have to do more work. 4 would not mess you up. You just have an additional step. So separate it. That will be 4 root 2 over 7. That makes sense. See how we're doing the exact same thing we did on part A up here? It's just that we had to separate the fraction first, and we did it on top. The bottom just turned out to be an easy one, so we didn't have to do much here. But that's the process. Any questions on 10? All right. Simplify. Oh, excuse me. I'm so tired. All right. 4 times cube root 128 x cubed plus cube root of 16x cubed. So I'll make you a side note here. You can only add radicals that are the same. Square root x plus square root x is 2 square root x, because there's 2 of them. These are not the same, right? The inside. So you cannot add them. So what you want to do is simplify and see if they change into something that is the same. And then you add them. If they don't, well, you just leave them as is and you're done. Like, for example, if I give you a question like this, I don't know, let's say it's 7. Square root 3 plus square root 7. That's it. That's the answer. You can't do anything. Does that make sense? So over here, we're going to do all the stuff we've been doing up here. Simplify the inside and see if they turn into something you can work with. If they don't, we'll just stop. See, if it turns into something weird like this, then you're done. Don't worry about it. So this will be 4 cube root 128. Is that a cube, or does it contain a cube? One 128. Does it have any cube factors? It looks like, yeah, 64. 64 works, that's right. Okay, so this is technically 64 times 2 times x cubed. This guy has what cube number is inside 16? Cubed. Yeah, kind of. Oh, you're almost there. When you cube root it, it'll be a 2. But yeah, we want to use the 2 as a factor. So 8 times 2 is what we want to use, right? I'm assuming that's what you meant. Excuse me. Okay. So we're all set up now. This 4 out here is just gonna leave it there for now. Okay. So what is the cube root of 64? I'm gonna put parentheses out here. The 64 would come out as a what in front? Yeah, it's gonna be a 4. So we got a 4 out here. Cube root of an x cubed, these would cancel, leaving you with just an x. So the only thing that does not come out is the 2. You see? Does that make sense? So these parts are cube rooted. I skipped a step here. I don't know if that's weird. Let me know. I can add an additional step if it doesn't make sense. Okay, so you guys are good then. Oh, keep doing it this way. Cube root of 8 comes out as a 2. Cube root of x cubed comes out as an x. Now I have a 2. So simplify the outside. 4 times 4 is 16. Cube root 2 plus 2x cube root 2. So now the cube roots are the same, right? So this is kind of like 16x or something plus 2x. What would that equal? Right, 16 plus 2. Yeah, exactly. So 18x, and then that weird thing here. So on these type, on number 11, you have to simplify everything and then add them together if it's possible. If it's not possible, let's say I got all the way to here and they don't do anything, then if they don't match, I mean, you just leave it alone. That's it. Who cares? You just stop here. This is like a 2 and this is a 4, or sorry, 2 and a 5. I don't know. The x 4 and 2. Where did the x come from? Is that what you're asking? Well, anything that is cube rooted comes out in front as a product, right? So the cube root of 64 came out as a 4. That's the cube root of 64 is this 4. Cube root of x cubed came out as an x. Cube root of 8 came out as a 2. Cube root of x cubed is an x. No, the x just everything just comes in front as a product. Right, this 4 was already there. 64 comes out as a 4. X cubed comes out as an x, and then you just multiply 4 times 4 times x. You get here. This comes out as a 2. This comes out as an x. 2 times x is just 2 times x. It leaves the inside, right? It's like when you have kind of like this one here. Square root of 4, right, comes out as a 2. I'm basically skipping this inner step. You just square root that part and you get to here. So if I had a bunch of junk in the front, you do multiplication, right? Like this. Any other questions on 11? for 81, I'd probably divide that by 3. Break that into 3 times 27, because 27 is cubed, Andrew. That 81 is also a square, so it kind of messes with your head, right? The answer would be 18x times cube root 2. Yeah. So part B, you do the same thing and then subtract if possible. If not, oh well. Well, is rationalizing. Do you remember how to rationalize a radical? So whenever you have a radical on the bottom, you were always told to rationalize and get rid of the radical. So you're essentially trying to kind of like square it away. So like this. I'm gonna turn this page. Let me know if you need me to come turn back. Let me see here. The type of radical. That have the functions. Usually you have like a box pop up. But do you not have a box come up, Joshua? Okay, because mine's on the has a solution, so I think mine's different. You can use commands, I guess. No, I don't know the command for Q. But anyway. Rationalize. Number 12, I think. 1 over square root 2. So since it's a square root, you want to basically force a square to happen. So what you do is you take the original, multiply by the same thing, right? That's how you square stuff. But since I don't have an equation, I have to multiply the top and bottom to keep it equal. Square root 2 times square root 2 is square root 4, which is why it cancels. So now it is rationalized. So when they say rationalize, they mean get rid of the radical on the bottom. That makes sense. That's all it is. Now, if you have a root plus or minus something, you have to use conjugates to help you. So in order to rationalize, you have to take this term here and multiply by the conjugate, which is this, right? Same thing, but a plus. So this becomes 5 times this garbage over. Down here, we get a difference of squares. I'm hoping this looks familiar. You see what I'm saying? Difference of squares. A plus B times A minus B is equal to A squared minus B squared. That should be very familiar. You remember? And if you don't, it's cool. I think I saw this first time, I want to say 6th grade, maybe 7th. So it was a long time ago. Right, but essentially all it's saying is we have the same thing, right? With a plus and a minus in the middle, you just multiply. You just square those two terms. That's it. Okay. So instead of doing all this ugly FOIL or multiplying, whatever you want to call it, distribution, what you can do is say, you know what? Well, this we can just go ahead and multiply. 5 times this, 5 times 5. There we go. Right. The bottom, the formula says if you have the same garbage, just differs by a sign being multiplied, you will get this squared minus this squared. See how that's much easier to deal with instead of doing this times that, this times this. I don't want to do that, right? I want to skip to here. So I'm skipping to there. So screw 35 squared, well, those cancel, leaving you at 35. 5 squared is a 25. See how that's much nicer. Which is a 10. We can still go further, right? But before we do you see any, do you have any questions on any of the steps? Okay. Sorry, I got distracted. I space out really bad all the time. Okay, so factor at the top part. Yeah, I probably should have left it factored now that I see this, right? 10 is technically 2 times 5, isn't it? So these cancel. So the final answer would be this guy. All right. That's it. That's as far as you can go. I think we're almost out of time here. That stupid setup took forever, but at least we're good. The rest is similar. So I think we'll next time we'll move on to P3, P4. But if you have questions from this section, we can talk about it whenever. No big deal. Okay. You have any questions about any of the problems from today? Usually we have extra time at the end for homework problems, but no, not today. I think we're all out of time. What you can do, just what I told everybody, message me on Remind and say, hey, can we go over this stuff in the morning, and I'll be ready via Zoom at 9 a.m. till 10:15. Maybe stay a little later if you need to. And if not, we could try other times. It might work better. We just got to plan it together. Eventually, I'll be tutoring at the lab as well. But yeah, there's Zoom tutoring, there's Zoom office hours, and then there's in-person tutoring. I'll also be there in person. All right. I'll let you know the hours. I haven't decided for my tutoring hours yet. I'll let you know though soon. Uh, it's all due on the 4th, but since we're, let me see. Stop recording already.